Okay, there is a second question from Mr. J. Beltran. Is he connected, partner? Okay, maybe we can check him in our Zoom class. Okay, anyway, so he sent this question to us. So I will answer his question, no? Even though he's not connected here. So just in case another student has the same question. No? Okay. So, okay, this is the question from Mr. J. Beltran. A coil has 6,000 turns of wire and a resistance of 380 ohms. The coil is rewound with the same quantity or weight of wire but has 12,000 turns. How many ohms will the new coil have? Okay, so I will show this with you. Okay, I will have a little derivation here. This is a topic about the volume resistivity. This is a volume resistivity. Let us consider a cable or a wire. So we have a wire here. Okay, we have a wire. Okay, it has a certain volume. So our volume is, it's like a cylinder, right? No? Para rin siya cylinder. So that's equal to the, what is the volume of the cylinder here? Okay, so that's equal to the area, that is the cross-sectional area, which is a circle, okay? And then multiplied by the length. Because this is the area, it has a certain area here, cross-sectional area, then it has a certain length. No? This is the length of this conductor. Okay? So we have a formula, by the way, for resistance. Our resistance is equal to rho, that is a Greek alphabet rho. No? Okay? When you see that, that is rho, that is RHO. Greek alphabet rho. Then we have here the length over the area. So we have this basic formula, right? For the resistance. Now, so R is equal to rho L over the area. Okay. So let us have this. From this formula, let us get the equation for the area. What is our area here? Our area will be our volume over the length. So let us substitute area to this equation. So we have here R is equal to rho. So we have here our L. Then what about the area? The area is V over L. V over L. Okay. So actually, this has L over 1, right? I remember my high school teacher. So she called this as the extremes over the means. Okay. So let us simplify this. So we have our R that is equal to rho. What is the extreme? L times L, so that is L squared. And then 1 times V is simply V. So we'll come up with another formula here. Okay. We may call this as formula number 2. Let's have this formula number 1. This is formula number 2. Then what about, let's get now the L. What is the equation for L in this formula? So our L will be equal to V over the area. Okay? So V over the area. So let us substitute L here in this equation, our original equation here. So we have here our R that is equal to rho. Then what about the L? Our L is V over A. V over A, then over A. So we can put here as 1 so that we can have here a extremes, an extremes here, the extremities, no, dulot-dulo, no, or the outer divided by the inner. This is the extremes over the means. So we'll come up with, so this is rho, so V times 1, simply V, then A times A, so that will be our A squared. So we'll come up with this third equation. So we have equation number 3. So these are the 3 important equations in the volume resistivity. Let us solve this problem. Let us apply our formula to this problem. So we have a coil, no? It has many turns of coil. This problem, so we have here 6,000 turns. Okay, so it has 6,000 turns. Okay, then it has a given resistance of 380 ohms. Let's say for the first case, 380 ohms. And then this coil is rewound. Okay, maybe it is being stretched and it is rewound. But now, 12,000 turns. Too many turns here. There. So we have 12,000 turns. How many ohms will the new coil have? So we have here our R sub 2. That is the question. Now, what formula are we going to use? Let's take a look at our formula 1, 2, and 3 here. Okay? So, anong formula gagamitin natin dito? Okay, we'll be using this formula number 2. What is formula number 2? So, our formula here will be R, that's equal to rho L squared over V. There. Okay? So, please take a look here to our formula. Okay? Rho, resistivity, square of the length, then we have the volume. Okay. Actually, the resistivity, this conductor is also this conductor. Vice versa. No? We are only talking of one conductor here. Okay? So, of course, no, this is the resistivity, okay? And the volume, since we are only talking to one conductor, that is constant. Constant. Now, we have here our R that can be represented by KL squared. Okay? So in here you will see that the square of the length is directly proportional to the resistance. Okay? The square of the length is directly proportional to the resistance. Here. How to set up now the equation here? So they are directly proportional. So I will put first R sub 2 over R sub 1. How we set up the equation? Okay, so we have to put a square here because of the square here in the L square. So I will put here L and L. So they are directly proportional. No? Always remember, no? When is the parameter directly and inversely proportional? It is directly proportional if that is numerator. And the volume here is inversely proportional because this is the denominator. Pag nasa ibabaw, directly proportional. Pag nasa ilalim, inversely proportional. Okay, klaro ba yon? So please listen carefully. Since we are setting up the equation or the relation between the resistance and the length. No? Since it is on the numerator, nasa ibabaw siya, no? So that is directly proportional. Directly proportional. So if this is 2, this must be 2. If this is 1, that must be 1. So 2 to 1, 1, meaning directly proportional. If we have 2, 1, 1, 2, that is inversely proportional. No? That is reverse. Baliktad yun. No? Okay. So, let us have this. We have our R sub 2 over R1 is already 380 ohms. So, that is equal to length 2 represent, let us just represent that by the number of turns. The length 2 is 12,000 turns. Okay. Then the length 1 is 6,000, the initial. Okay. We can make this as L1. This is L2. Okay. So this is 6,000 turns. Then we have to square it. Then we just have to cross multiply the 380. Then manipulate this using our calculator. Okay, our answer is 1520. Okay, that is 1,520 ohms. So this is my answer to Mr. J. Beltran. So the answer would be, let's take a look here. 1520 is letter A. There you are. Okay? Letter A. Then there is another question, again from Mr. J. Beltran.